In this video, we will continue discussing production theory for two inputs and how we can find the budget with these two inputs. And for this problem, we're given Q equals 6L to the 1/2 times K to the 1/2. The price of labor is 50, the price of capital is 90, and the maximum quantity we can produce is 200,000. And we're asked to find the marginal productions of labor and capital, production maximizing labor and capital, and the budget that we're given. So first up, let's find our marginal productions of labor, which is the derivative of Q with respect to L. So we have the part that we leave alone, so the 6 times K to the 1/2. And then the part we take the derivative of the L to the 1/2, so we have 1/2 times L, and 1/2 minus 1 is negative 1/2. And if we were to simplify that a bit more, we have a marginal production of labor of 3K to the 1/2 over L to the 1/2. Now if we were to find our marginal production of capital, which is the derivative of Q with respect to K, we would have the part that we leave alone, the 6 times L to the 1/2, and then that would be multiplied by the derivative, which is 1/2 K to the negative 1/2. And if we were to simplify, we have MPK, marginal production of capital, would be equal to 3L to the 1/2 over K to the 1/2. And so we can use the relationship stated by the marginal rate of technical substitution, which states the marginal production of labor over the marginal production of capital is equal to the price of labor over the price of capital. So if we start plugging things in to the MRTS, we have 3K to the 1/2 over L to the 1/2 over 50 is equal to 3L to the 1/2 over K to the 1/2 is over 90. And by simplifying a little bit, we have 3K to the 1/2 over L to the 1/2 times 1 over 50, and that is equal to 3L to the 1/2 over K to the 1/2 times 1 over 90. So that gives us 3K to the 1/2 over 50 times L to the 1/2 equals 3L to the 1/2 over 90 K to the 1/2. And so we can cross multiply from here. And by cross multiplying, we're left with 270K equals 150L. And if we solve for L by dividing both sides by 150, we are left with L equals 1.8K. And so our input ratio is L equals 1.8K. And since we were given a maximum quantity at the beginning of this problem, we cannot use the budget function that we used in the previous problem. We have to use the quantity function that was given to us. So we can have 200,000 equals 6, and if I were to plug in the 1.8K for L, I would have 1.8 times K, and that entire thing would be to the 1/2 power times K to the 1/2. And so I can distribute this 1/2, so I can have 200,000 equals 6 times 1.8 to the 1/2 times k to the 1/2 times k to the 1/2. And so I still have that 200,000 on the left side, and on the right side I will have 8.05 times k, because k to the 1/2 times k to the 1/2 is k to the 1. And so if I divide both sides by that 8.05, I am left with a k equals 24,845.2. And by plugging this k back into our input ratio, we have L equals 1.8 times the 24,845.2, and L equals 44,721.36. And last but not least, we can find our budget using the budget function, which is m times p of L times L, plus the price of k times k. So if we plug things in, we still don't know what m is, and the price of L is 50. We know L is the 44,721.36 plus the price of k, which is 90, times 24,845.2. And by plugging all that into a calculator, we are left with m equals 4,042,135.96. So this is our budget for our production. This will conclude the video series on production theory.